a contract. So what a contract is in Ethereum is basically it's a piece of Ethereum code. So we have a programming language called Serpent. It's basically like Python that you can use to actually write the contracts, and they get compiled into this sort of low-level machine-like language. And then you would put that code into a transaction, push the transaction to the blockchain. And then once that happens, the contract will have an address. And then if somebody else wants to interact with that contract, then they'll be able to just send messages to that particular address. Yeah.
Now, let me ask you about, let's say, the top other 3 or 4 apps other than currency. What would be the most interesting ones?
Sure. So the way I generally classify Ethereum applications is in 3 categories. So one category is financial, which involves either currencies or better ways of managing your currency. So the better ways of managing your currency would include either various different things like financial derivatives hedging or things like escrow. So for basically ensuring either consumer protection or just personal security. So one of the ideas that we always float around is, well, what if I want to store my money in such a way that it's I use some kind of bank as sort of a cosigner. So even if my private key gets stolen, nothing bad happens. But at the same time, control the bank and don't give the bank all the power. So that's something that Bitcoin can do to some extent. That's something we can do better. The second category is semi-financial. So semi-financial is things like decentralized Dropbox. It's something we talk about a lot. Basically, the idea is you can have an Ethereum contract that can request cryptographic proofs that you're storing a particular file, and if you are, then it can give you a micropayment. So you basically have a contract and you upload a big file, and then the contract just automatically rewards people for storing the file on a per hour per gigabyte basis.
Basically, I'm renting out my hard drive space.
Exactly.
Okay.
And there's it's a lot harder, but there are also ways to rent out computational time as well. Theoretically, even bandwidth. So the idea is that if you've got a computer, your computer really has like 4 miners in it at the same time. It's got a miner for, you can mine Ethereum itself, then you can do some more mining with your CPU by running one of these computation for hire projects. Then you can mine a bit more with your hard drive, and then finally you can mine a bit more and participate in the mesh network with your wireless router. So that general category, I would say, is what I would call semi-financial. And there's a lot of very interesting ideas in the semi-financial, and especially in the micropayment space. Especially if you get into sort of the bigger picture, things like rolled tools, for example. You can imagine if you have a sort of perfect market-based rolled tool system that would automatically charge you more for driving at rush hour towards downtown and a bit less if you were driving in the middle of the night somewhere far away and so forth. You'd basically be able to replace half of urban planning with this market-based system that just automatically aligns incentives for people to do exactly the right thing. Then there's just general resource allocation problem issues and so forth. Then the final category is, of course, the non-financial. So non-financial basically means things like decentralized governance. So people have been talking a lot about how do you run a non-profit organization or a for-profit organization like purely on the blockchain. So we've been using terms like decentralized organization, decentralized autonomous corporation or organization. So this idea that all an organization really is people with a set of resources and mediated by a set of rules. And what if you have a set of rules enforced very efficiently and cheaply by the blockchain? And together with that, there's of course decentralized voting. And finally, there's also these sort of other first-to-file systems that have nothing to do with money at all, which would be reputation systems. We've talked about domain registration, name registration in general. So for example, if I wanted to make a decentralized Twitter, one of the challenges is, well, okay, on the normal Twitter, we all have handles. I'm at Vitalik Buterin, I'm sure you might be something else and so forth.
At
but
Singularity
at
blog.
Singularity blog, perfect.
Yeah.
So that name database is stored on Twitter servers. If you want a decentralized Twitter, then guess what? You need a decentralized server to store name registrations. And that's what blockchains are extremely good for. And then we've got reputation systems, credential systems, social networks, and so forth.
Mm-hmm.
Yeah.
That's brilliant. So let me try and push you a little bit more on each of those points and see how far we go. Mm-hmm. So let's start with, let's say, decentralized Dropbox. Mm-hmm. Now, help me here to figure out how it's actually going to work in practice, because let's say a guy like me, I have probably about 1 terabyte worth of backup stuff on my computer. Now, one of the reasons why I'm using local backup storage at home rather than back it up on Dropbox is bandwidth, right? Imagine having to back up 1 terabyte worth of data. Rogers is going to basically overcharge me to the end of the world for so much data transfer. So that's one issue. The other issue is also that I foresee is, so one is the bandwidth clogging with, let's say you have 10 decentralized nodes that are sort of syncing in among them. Wouldn't that gobble out all the possible bandwidth? And then on top of it, you have the actual size of the database, right? In my case, it's 1 terabyte. Young kids nowadays have videos, large pictures, MP3s, movies, all kinds of large files. How are we going to overcome these two issues?
So one of the major important points is that it's not like we're going to be storing your 1 terabyte on the blockchain. It's a very common misconception, but that would cost you something like $20 million.
Exactly.
So the right way to do
Just for Rogers.
Yeah. Well, yeah, Rogers would charge $4 million. The transaction fees for the blockchain would be another 20. So the right way to do it is it's basically upload the file exactly the same way you would upload a file over BitTorrent now. So that's basically that's one approach. Or another approach is to actually find a few dozen specific nodes and give them each a certain piece of the file. So there's a set of algorithms called secret sharing algorithms that basically let you take a big file and
break it apart.
Break it up into pieces. So let's say, so here's the trick. You take, say, a 1 gigabyte file. You split it up into 30 pieces of 50 megabytes each. So notice 30, not 20.
But then it's not really decentralized, because if one of those 30 pieces is dead, I can't have my file.
See, that's the point of the secret sharing algorithm. I said 30, not 20. 30 times 50 is 1,500 and not 1,000. So the idea is this algorithm, it automatically sort of builds in optimal redundancy. So you can take any 20 of those 30 pieces and you can get the original file back.
Ah, that's cool. That works, yeah.
Exactly.
Because my concern is, as you know, as I said, but you already addressed it. Brilliant. Okay, so let's talk a little bit more about the sort of the micropayment option, right? So how would you address those people who don't have Bitcoin to pay for road tolls, for example?
Yeah.
Because one of the issues obviously here is equality or equity. I mean, some people have already accumulated enormous amounts of Bitcoin. Actually, one of the reasons why science fiction writer Charlie Stross says that Bitcoin should burn in hell and would never work is that it has a terrible Gini index. That's in terms of its equity between people who own Bitcoins. Right? So it's actually worse disseminated than, let's say, any totalitarian country in sub-Saharan Africa. Right? And it's getting worse according to him. So the idea is basically if people don't have Bitcoins to pay for road tolls, how are they going to do it?
Yeah. So the important thing about Ethereum specifically is that, once again, we're not a currency, we're a platform. You can use whatever currency you want. So assuming this kind of road toll application is going to actually go mainstream, you would assume that whatever government would perhaps either issue their own sort of token system, and they might even decide to say give every person 20,000 tokens for free. And so the idea is that you would only actually need to end up paying if you're an above average user, and if you're a below average user, you can even earn a bit of money from the system. So it's basically you can plug in whatever currency you want. You could potentially use some kind of blockchain-based dollar token. You could have Bitcoins, Ether, or Euros, yen, whatever you want.
My concern is also for those people who are totally technologically sort of Luddites.
Yep.
Let's say you're Amish. You have your horse and your buggy, and you're riding on the same roads that we're driving our cars. How are the Amish going to pay for the road toll if they don't even have a cell phone? They can't even make micropayment, right? So there are going to be a certain percentage of society who are never going to adopt any technology, right? Whether you're homeless, whether you're Amish, whether for some other reason.
Yeah, I mean, it's that's, I think, one of the biggest challenges with phasing in technology in general. It's basically the infrastructure problem, and I think a lot of the stuff we're actually probably going to see adopted pretty much in the third world first, and in more developed countries later on, just because they haven't had any existing technology that they're used to, so they can leapfrog over immediately to the new stuff. So yeah, there's always going to have to be some kind of mechanism for transitioning over, some kind of alternate solution for people who haven't moved over yet. It's I'm optimistic that we can find a way around that.
Yeah, because I think the devil is in the details, and the implementation there can actually make or break it, the success, right? Because if it's not implemented right, it could totally lead to failure, and if it's implemented right, it will be absolutely revolutionary, obviously. Now, talk to me a little bit more about the sort of decentralized app ecosystem, because I think that's a very important feature. How is that going to look like? What is it? What its main value proposition?
Right. So the idea is that right now we've done quite a lot of work on building the Ethereum protocol and building the Ethereum clients. But in order for Ethereum to actually be useful, you also need to have a large number of applications. So this is just one of the other ways that we're addressing the problem of, well, most people aren't too technical to be able to use something as advanced as Ethereum. And the answer is, well, they don't have to. Most people aren't technically advanced enough to use JavaScript, and yet they're still benefiting from it. So it's what we're trying to set up is we're trying to set up this ecosystem of basically apps, or we're calling them dApps, where each dApp is a combination of whatever contracts and an interface. And the idea is to take something like decentralized Dropbox or something like this name registration idea or decentralized currency, and turn it into just an application that's maximally easy to use, just point and click interface, looks just like any other currency. And so what we want to set up is basically have what's like the Android of cryptocurrency. So in the Bitcoin space, the Bitcoin client and the Bitcoin wallet are synonyms. In Ethereum, that's completely not true. In Ethereum, the Ethereum client is more like Android, and the Ethereum wallet is more like one of the apps on top of Android. So in order for the whole ecosystem to work, we need to build the Android. We also need to build the equivalent of the Google Play Store. We'd also ideally, we like to eat our own dog food. We want to have the reputation system and the consumer protection systems for all these different app ecosystems, also based on the exact same technology that we're trying to develop. So that's something that we're really going to be pushing forward over time, especially once the client's implementation begins to solidify.
Let me ask you a little bit back again on the database issue. Now, I know that it seems to me at least one of the reasons why Bitcoin is being implemented and spread so easy is because the size of the blockchain, the database, is tiny right now, right? How is the Ethereum database size going to compare? Because apparently it seems to me as an ignorant software person that it would have to be much bigger, probably an order of magnitude, if not more, to be able to accommodate a whole platform that's Turing complete.
So the interesting thing is that in some ways Ethereum is less efficient, in some ways it's actually more efficient. So, for example, two of the architecture decisions that we made with Ethereum as opposed to Bitcoin is that Bitcoin is based on this concept of unspent transaction outputs, UTXO. The simplest way to think of it as being coins. Basically, the Bitcoin database is a database that tells you here are all the coins, and here's the denomination and the owner of each, or the script that owns each particular coin. And so, for myself personally, I would probably have like at least a few hundred of these coins of various denominations, from some number of BTC to like 6,000 Satoshis. In Ethereum, our approach is account-based. So you have one account and you just store a balance. So no matter whether you're just some new user that got one transaction or whether you're Mt. Gox and you got like 20,000 transactions, one account, it's like 100 bytes. So the other thing is that...
You can fit all that in 100 bytes?
Well, so no, in Bitcoin you can't because Bitcoin's got a whole bunch of coins. In Ethereum, it's basically, you've got the account, then you've got the balance of the account, and that's basically all you care about.
And where's the rest of it? Where's the actual coins if
they
you just have the balance?
Yeah, it's the actual coins don't exist. It's just like a bank database. A bank database, it's like a table. George 45, Mary 2000, Bob 1500, and so forth.
Okay, but my understanding was that you do have like actual coins that you transfer, right? So that's the coding thing from Bitcoin, from Satoshi. That's one of his original contributions.
Yeah, so Satoshi's Bitcoin architecture was definitely dependent on this idea of, well, we have coins, and in order to create a transaction, you have to spend existing coins and create new coins. That's an architectural choice that he made. It's not a necessary one. It's only one of the two ways to do it, right? As the fundamental idea behind Bitcoin is that it's a consensus system that's backing up what's basically a state transition system. So the consensus system tells you what transactions happened in what order, and then you have the state transition system, which is, well, if you have this set of existing coins, it'll tell you whether this transaction is valid, and if it is, then what coins to take out and what coins to add in. So in our system, it's actually more traditional. We're basically saying, here are all of the accounts, and what transactions do is a transaction subtracts money from one account and adds money to another account.
And how do you avoid the copying issue?
Yeah, well, it's the rule is simple. So there's a database which maintains how much money each account has, and then the rule is that, let's say I have 50 Ether in my account. I publish 2 transactions. One transaction sends 40 Ether to you, another transaction sends 40 Ether to my friend. So publish both of them. Suppose that the transaction to you comes first. That transaction gets applied, and let's say before that you had 200 Ether. So then the database gets updated. It goes from 50 me to 200 U to 10 me, 240 U. And then that's the new state of the system. Then the second transaction comes along. Then the miner tries to process the transaction and notices, oh, this account only has 10 Ether left. It's trying to send 40 Ether. Not enough money. And it just returns an error. It's exactly like a banking database.
And if you return an error, do you charge a fee for that computation?
It's actually somewhat complicated because there are
because it takes some resources to calculate that, right?
Actually, in that particular case, yes, you do. So yes, you as the sender of the transaction do have to pay the fee, but the effect gets reverted.
What do you mean the effect gets reverted?
So basically, the transfer of 40 Ether never happens, basically. So the other point there is that if you have let's say you send a transaction into a contract, but you only pay for 10,000 computational steps.
Yeah.
But then the contract execution suddenly becomes a lot bigger than anyone expected and starts taking up more than 10,000 computational steps. Then as soon as you hit the 10,000 mark, all those computational steps, if they had an effect on the system, the effect gets reverted, it gets taken back to the start, but the fee gets paid anyway.
Yeah, but if the fee gets paid anyway, let's say I misjudge and calculate the steps necessary, does that mean I can kind of empty out my account in fees that could gobble out all my balance without actually accomplishing...
No, so the one point there is that you do have to explicitly consent to every reduction in your balance, right? So if you send a transaction where you pay for 10,000 computational steps, there's no way you're going to lose more than 10,000. And the other thing is that the general strategy that I expect clients will take is that they'll sort of run the transaction just simulated locally. They'll see how many steps it'll take, and then they'll send a transaction with that plus a safety margin. Say something like 2x or 4x. So the chance that it'll fail is really low, and even if it does, then you just send it again.
How secure is that system, Vitalik?
It's Against what kind of attacks?
Well, let me give you an example. Jordi Rose, who is the Chief Technology Officer of D-Wave quantum computers. And we talked to him a lot about, because obviously encryption is key feature of this whole platform. And we talked to him about breaking code with their computers. And Jordi's answer to this was basically, we're not interested in that space. We're not going to use our machines for any of that space. But my response would be like, yeah, but somebody will, right? And once you sell that computer to a third party, you have no control pretty much of how it's being used. So let's say you have and there's, I think, 3 quantum machines up to now.
Okay,
Would this be secure in terms of breaking the codes in it with a powerful machine like that?
There's a lot of misinformation out there around quantum computers. So first of all, D-Wave's quantum computers, they're adiabatic quantum computers. Adiabatic quantum computing is basically this clever strategy where you try and solve computational problems by reformulating them into energy optimization problems. So basically you align some particles in such a way that the lower the energy state of those particles is, then the better a solution to a particular problem is. So the idea is that you would use the particles themselves would use quantum computing tricks to sort of magically enter the lowest energy state that they can. So an important point is that that kind of quantum computing, it's not really real quantum computing in the sense that a lot of people think about, right? There's actually only a very limited class of problems in which it's better than conventional computers at. Generally, when people talk about quantum computers, they talk about these things like Shor's algorithm and Grover's algorithm that can solve problems like factoring much more easily to the point where RSA and ECC pretty much become trivial.
Obsolete.
Yeah. So those kinds of like actually powerful quantum computers, they're still quite far away. Yeah. Like the most powerful quantum computer so far of the sort that can do Shor's algorithm just used it to factor the number 21. So we're still in the 5-bit days here.
I totally agree, but my concern is this, right? If Bitcoin is here to stay, it will be here 10 or 20 or 30 years from now, and the same applies to Ethereum. And those algorithms would be locked. Would they not be locked? Would they be able to evolve? And my concern is that 15 years down the road, instead of mining with a desktop, some smart and rich fellow may start mining with a quantum machine better than what we have currently today, and then we'll be able to sort of cheat or break the system, break the cryptos.
Yeah, so the one thing we're trying to do with Ethereum in the long term is actually try to remove this notion of having certain intrinsic algorithms. So right now, every account is protected by elliptic curve DSA, but in the future, we want people to be able to use the exact same contract mechanism and basically just choose whatever crypto they want. So there's an interesting kind of digital signature. It's called a Lamport signature that you can use to basically sign messages just like ECDSA, except it's quantum proof. So the two big reasons why not everybody's using that yet is, first of all, it's less efficient. So a Lamport signature for 160 bits of security takes up 800 bytes as opposed to 64 bytes. And the other thing is that it's a one-time signature. So there is a construction where you can turn that from one-time signature into like a 20,000 times signature, but even still it's limited. So there are definitely ways to do it, and we are actually looking right now at how try to integrate those different signature types as options. So it's definitely something we're thinking of.
Yeah, brilliant. And based on what you're telling me, I'm optimistic that you're thinking about that, and especially if the algorithms are not locked but can evolve over time, that's fantastic. Vitalik, tell me, what, in your opinion, is the biggest misconception about either Bitcoin or Ethereum or both that you want to really dispel? Something that's really probably annoying or you get to encounter way too often for your liking.
Well, the Turing completeness one is actually pretty important. I would say the bigger one just for average people is that Ethereum is not a currency. So Bitcoin is but a currency, but Ethereum, it's this abstract platform that lets you do pretty much anything that you want, right? So a lot of the time people like to criticize Bitcoin for things like deflation, fixed supply, certain particular aspects of its economics, or even the idea of having a non-government backed currency and so forth. Whereas with Ethereum, like all of that is really quite separate. So as I was saying, there is Ether, but at the same time, there's the opportunity to have pretty much any kind of currency on top of Ethereum.
Singularity coin, yeah. We're launching it soon.
Exactly. Singularity coin on top of Ethereum if you want.
Brilliant.
Yeah.
Now, tell me, where do you see Ether in, let's say, or Ethereum, in 12 months and in 5 years from now?
Yeah. 12 months, I would say. So the first 6 months are going to be heavily dedicated to getting Ethereum actually to the point where we're ready to launch the main blockchain, get Ethereum 1.0 out. Once that happens, the focus is going to heavily shift pretty much entirely on the space of applications. So I've already talked about some of the different sort of infrastructure that we need in order for Ethereum to really work. Things like name registration, reputation systems, security, also data feeds for financial contracts are very important. So all these different ecosystem details that can make the ecosystem so much better. That's something that we'll be probably working on all the way through 2015. At the same time, another important point is that, Ethereum 1.0 is not the end. We've got quite a lot of good context in cryptography, and we are probably almost certainly going to release Ethereum 2.0 sometime around 2016 or so, which will hopefully have much more advanced cryptography protocols that will really solve the scalability issue to a much greater extent. Because scalability, we're doing all that we can, but at the same time, there's this fundamental issue that every node has to process every transaction. And for 2.0, we're going to see if we can break that.
And what if it becomes way too popular and there's way too many people using it beforehand? Wouldn't you run into that problem faster than you expect?
So the nice thing is that Ethereum, even 1.0, it sort of gracefully decays. So there's this concept of a light client where you can use the blockchain securely without having a full node. And that's something you can do with Bitcoin, but it's something that we're going to be very specifically, explicitly supporting in Ethereum. So how to basically make the currency still fully secure, even if there might be only like 100 full nodes running in the network on big servers. The idea is that as long as even one of these large server nodes is honest, it can sort of act as a watchdog and it can point out where the errors and any sort of fallacious blocks are, and all the light clients will easily be able to find out.
Because my concern is what happens in the moment where you have millions of nodes.
Yeah.
Would we gobble out the internet, the bandwidth, everything, just trying to sync between those nodes?
The thing is that it's
let's say 100 million nodes.
Yeah, it's a fundamentally economic problem, right? If there are 100 million nodes and there's 100 billion transactions on each node, then most of the nodes are not going to be able to afford to keep running, and they're going to have to switch to light clients.
Precisely my point, yeah.
Yeah, so somewhere in between everyone running a full node and a combination of full nodes and light clients is where probably the balance is going to be. And that's probably the best we can do, at least until the point where Ethereum 2.0 technology really becomes ready.
Yeah, the good thing is we don't have to solve the hardest problems at the beginning, right?
Yeah.
But only once we get there. So, Vitalik, tell me, let's say many people by now might be wondering, how do I get involved in Ethereum? How do I buy into Ethereum, or how do I get Ethers? When do you guys launch, and how can people like me or anyone interested become a part of it?
Yeah, so if you want to join Ethereum, the simplest approach is really just start contributing. We have repositories for code if you're interested in programming. It's open source. You can submit patches just like any other project. That's actually really how most of our current team came in. Then if there's something else that you want to do, then you just contact any of us. We're quite public, spend a lot of time on the Reddit and the forums. If you want to be a partner, if we have a lot of opportunities in the ecosystem. We've been talking about things like financial markets, some of these ideas around micropayments. A lot of them we're definitely not going to be able to do ourselves, and we really want to work with other organizations who can help us and have the experience and the connections and the knowledge to be able to actually implement these kinds of systems in reality. So if you think that you have an opportunity where we can work together on that front, contact us. We're available by email.
When do you launch?
Yeah, so when we launch, so the next big milestone is the Ether sale. So this is when we're basically going to be selling the first few units of Ether. It's basically unlimited at 1,000 Ether for 1 Bitcoin, or 2,000 if you buy in early. And that will be the way to buy Ether at this point. And then once the Ethereum itself launches, of course, you'll be able to get more Ether either by buying it off the market or by mining. So mining is something that, unlike Bitcoin, Ethereum is going to keep on releasing new units of Ether forever at a fixed rate. Mm-hmm. And
but when would people be able to buy?
So when the sale, at this point we are looking at something like a week or two. It basically depends on some final legal and computer security issues. Mm-hmm. Yeah, and the Ethereum blockchain itself, we are hoping for we are setting ourselves the target of the second half of the year.
Mm-hmm. Now, let me ask you a little bit about that exchange rate, because that's a crucial part of that sale. Mm-hmm. You said 2,000 for 1 Bitcoin if you get in early, because obviously there's a higher risk, and then 1,000 later. But that's kind of like fixed exchange rate. Who makes that decision, and why at that level? Why not 10,000, for example? Why not 100? Yeah. Why not 10? Why not one-on-one?
Well, the thing is, it doesn't really matter, because if it was 2 million Ether for a Bitcoin, then there would be 1,000 times as much Ether, and so it would be 1,000. Each unit of Ether would be 1,000 times less valuable, and it would be equivalent. So it's basically just a matter of sort of how much do we want each individual unit to be worth, and at this point we feel that having each unit of Ether start off by being worth $800 is just a bit too inconvenient and expensive. So right now we're basically targeting something like 25 cents, which is what 2,000 Ether for a Bitcoin gives you.
Okay, but that's part of the equation. So that's your target of what you want it to be worth, but it doesn't make it worth
right.
so.
Right.
So it's one thing to have, I want it to be worth that much. It's another thing to be actually worth that much.
Yeah, so the idea here is that in a normal fixed supply sale, the organization chooses the supply and the market determines the price.
Exactly.
Here, we're determining the price and the market determines the supply. So
what you're saying is, if people think it's too expensive, they wouldn't buy it.
Yeah.
I see.
Or rather, if people think it's too expensive, then fewer people would buy it.
Yeah, and the price would naturally fluctuate down, hopefully.
Yeah. So the idea is that if for some reason everyone thought that there is no point in buying Ether is way too expensive, and let's say only $400 got pushed into the sale, then you might see, oh hey, I can throw in $100 and I'll get 20% of all Ether in existence, and that'll be a very good deal for you. And somewhere in between that and a much higher number, it would be the balance.
Yeah. But that's one of the scenarios where we run out into those Gini distribution issues, right? Because if one person becomes too big in the beginning when the currency launches, if one person has even just 20 or 30% of all Ether coins, then wouldn't that kind of create a huge disbalance from the get-go? Yeah,
that's... Exactly. That's actually one of the reasons why we wanted to have this kind of sale. Because if you look at what Ripple did, Ripple followed the just sell to venture capital strategy, which is legally easier, but it ensures that the Ripple currency units are concentrated in the hands of a few people.
Yeah, venture capitalists.
Yeah. And then the other issue is that, a lot of people ask us, well, what's the cap? What's the final supply of Ether? And we say, well, there is none. It keeps on growing by a fixed quantity every year, where that fixed quantity is roughly equal to 30% of the initial supply. So the idea there is that the supply keeps on growing, and so it's not like there's this one fixed pie that you can gain 5% of forever. That's probably our biggest difference compared to pretty much all other existing like Bitcoin and altcoins and Ripple.
Now, Satoshi did mine many of the original coins in the beginning. Now, you have played a crucial part, obviously, in Ethereum. Would you be remunerated in any way at the launch? So, in other words, would you be assigned a certain amount of
So
coin?
our current strategy is to say that we have... so this is still not quite finalized, but our current strategy is that we have 3 pools of Ether. So one pool is the pool that we sell. The other pool is the infinitely growing pool that's going to get mined. And the third pool is a small pool, roughly something like 30% of the Ether that we sell is something that we're going to use as an organization to pay for development long term. So
30% will be for development?
It's, well, technically 22% of the initial supply.
Okay.
That looks large, but it actually isn't that large because it keeps on going down with mining anyway. And so...
It gets diluted over time.
Yeah, it gets diluted over time. So the distribution of that basically started in December.
Yeah.
Yeah.
And you've been participating in that, I imagine.
Exactly. So, yeah, so of that particular slice, like maybe actually only about a few percent have been allocated so far. The rest of it is basically something that we'll use in the long term in order to build out the ecosystem, things like the cryptocurrency research group and so forth.
And how many coins? Is there a cutoff point, just like with Bitcoin? At a certain date, there will be the last mined Ether ever.
No.
So how's that going to work?
Yeah, it's so let's assume that we sell 10 million units of Ether. Then the idea is that there will be this 3 million endowment slice, of which about a quarter's pays for development so far. Then a larger amount pays for pretty much everything in the future. And the reason why it's so large basically is that we need a lot of pretty much all of our developers actually wants to be paid in Ether to some extent. So we need to have some way of satisfying that, and it actually makes more sense to just assign ourselves the Ether and get a bit less Bitcoin from purchasers rather than using the Bitcoin and buying from ourselves. So
that's one of the best signs that people believe in what they're doing, I think. They don't want to get paid in dollars, but in Ether. That's pretty awesome.
Right, yeah. So going back to the example, so 10 million sold, 3 million endowment, and then 3 million mined every year. So.
And is there a point where you stop the mining process, like 2021, like Bitcoin or something? I don't know.
No, it's not. So after, say, 10 years, it'll go up to 40 million. After 100 years, 310 million. After 1,000 years, 3.01 billion, and so forth.
Because that leads me to one of the most common criticism to Bitcoin, which is to say it's deflationary, right? Because it has a fixed supply from the get-go by design that cannot be changed. And it would appear that Ether would not suffer from that issue.
Right. So we're basically taking a very fine balance there. We're not really inflationary because the percentage rate at which the supply grows still tends to zero over time. Like after 1,000 years, it's 3010 million. After 1,001 years, it's 3013. So that's a 0.1% growth there. But at the same time, the supply actually keeps on growing by a fixed amount over time. Yeah, so we're basically trying to find the right balance between the two there.
Fantastic. Well, Vitalik, we've been talking for over an hour today, and it's been absolutely a pleasure to discover myself and for myself more about Ethereum, and I really appreciate that. But let's say people would like to find more about you and your work. What's the best place for them to do that?
I would say first stop is definitely our website, ethereum.org. That's where we have links to our forum, our blog, our wiki. There, on the wiki, we also have links to our white papers. So that describes what Ethereum is, what the motivations are. There's even a very formal protocol specification. On the blog, if you want to really get down and dirty quickly, there is a programming tutorial. It talks about how to write contracts, and the forum and the Reddit to ask questions. and just sort of keep on going from there.
And if our viewers and listeners were to take a single message from our 1 hour conversation with you today, like the most important thing that you'd like them to remember, what would that be?
Yeah, I would say it really boils down to this idea that Ethereum is not a currency. It's basically, we've had this idea of decentralized consensus technology for 5 years now. Bitcoin's done really well with it, but really you can use it for so much more. And I think now is actually the time when we're starting to move away from just, let's have a decentralized currency for decentralized currency's own sake, and actually realize that there's all sorts of these different applications where you could actually do so much that you can't even do in the existing paradigm at all. So, or if you can, it's extremely inefficient. So one of the paradigms one of the examples that I always like to bring up is actually gambling. So in 2006, for example, if you wanted to make a gambling site, it would be extremely difficult. Like, you would need to have a relationship with a payment processor, you would need to get a VPS, you would have set up a server, get a domain, make sure your database is secure, protect yourself against DDoS attacks, and so forth. In 2012, it got a bit easier because you got Bitcoin, and with Bitcoin, you can actually do all the currency part without most of the security, without the payment processing, and so forth. In 2014, guess what the gambling sites of the future are going to look like? They're just going to be Ethereum contracts and 15 lines of code. Write them once, click compile, click push to blockchain. Push the blockchain returns to you an Ethereum address. Paste the Ethereum address onto a forum, and bam, anyone can gamble.
Well, I can see how the casinos are going to love you for that, but
yeah,
I'm personally one of those crazy people who believe that it's good that it's hard to get involved into gambling.
So, yeah, it's just it's an example. Yeah, it's an example, right? It's the idea is that you're taking this industry where things are very hard. It's actually very bad for consumers right now because it's very easy for gambling sites themselves to cheat, and so. And with Satoshi Dice, you have this idea of provably fair gambling, where you're actually introducing the idea that the site itself can't actually cheat, because if it cheats, it becomes immediately obvious. You use cryptographic algorithms to prove that it's...
You're not using a loaded dice.
Exactly, you're not using a loaded dice. And here, you're not even choosing the dice. You're writing the dice into the contract, and everyone sees your dice. And they're seeing your dice as they're getting executed.
I get that.
Yeah, so the other, So, once again, it's an example, right? That's, gambling is, it's such a nice example because it's this sort of pure financial service.
It's not my favorite example. So let's do one better than that. Let's give something better. I don't think I personally don't think we'll change the world with gambling.
I know. So a good example might be Kickstarter is also another one.
Okay.
So Kickstarter is once again, it's a great idea. You can actually grab funding together from thousands of different people. People can start these large, well-funded projects without having to go to a VC. It's good, but at the same time, it's also inefficient. You need to deal with all the same merchant account difficulties. Kickstarter themselves takes a pretty large cut.
They take between 4 to 8%. I've dealt with them.
Yeah, and there's all the other sites take a pretty good cut too. So there's and at the same time, they're also geographically limited. If there's a lot of countries, I'm sure you can't really access them at all, right?
Actually, that's a great example because it's not true. Actually, it's much higher. I remember I ran a crowdsourced fundraising campaign myself, and actually, in the end, I lost about 12% of the value that was given to me, because part of it was taken by Indiegogo, part of it was taken by bank fees, and part of it was lost in the conversion process in the exchange rate from US dollar into the Canadian dollar. So in the end of the day, when I did the math, it was somewhere between 12 to 14% of the value that was lost in transaction before it actually even got to me.
Yeah,
so I think that's fantastic, because the transaction fees will be what, 0.5% or less?
Yeah, it's pretty close to zero, really. So here, the advantage is it's basically that actually I remember when I released that programming tutorial that I mentioned, I released that at like 2 o'clock in the morning. I woke up again at 6 o'clock in the morning, and I found that someone had already used that tutorial and they had managed to write up a Kickstarter contract in 30 lines of code.
Wow.
Yeah.
And that's the kind of exponential change that we're talking about and that this show is all about. So,
exactly.
Vitalik, I have to say, I'll be watching very carefully and very closely and very curiously how Ethereum develops as a project and your future, because I believe you have a very bright future, my friend. Sure. So thank you very much for being with us today. Thank you.